Okay, so this one, I want you to start by doing this problem, but not moving it up 8. And it was 5 sine of 3 pi theta. All right, so I'm going to go up here. Here's normal sine. Here's 1. Here's -1. You change that to 5 and 5. Because why? Because it's a 5 sine. And then there is a 3 pi theta. That 3 pi is critical. That 3 pi tells me you've got to move these numbers. There were 2 pi and pi over 2. And I like to count it up. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, which is the same as 2 pi. And then I have to know enough to say that right there, you divide all of your horizontal numbers by that. Do you remember that whole, like, when it's on the inside, it does the opposite of what you think? It does not make it get 3 times bigger. It gets 3 times smaller. So we divide it by 3. Okay, so I'm dividing everything by 3, or multiplying by 1 over 3 pi. 3 pi, 3 pi, 3 pi. Simplifying them all down, pi's cancel, 1/6. And then as soon as you know the first one, oh, it's so easy. 1/6, 2/6, 3/6, 4/6. Did any of you do that? Anybody do it that way? Anybody in the room do it that way? Because that's a really smart way to do it. Awesome. Just figure out the first one, and then just kind of go 1, 2, 3, 4. Count by that. Yes? I will not mark these wrong if you don't reduce them. That's a very rare thing. Normally you have to reduce everything. But in this case, it actually makes more sense. Like, sounds not right. 1/6, 2/6, 3/6, 4/6, as opposed to 1/6, 1/3, 1/2, 2/3. I mean, they don't flow at all. So I like it when they flow, and I like it that you notice that they flow like that. So I'm fine with you not reducing them. Yes.
On the test, you have to show what it starts with, or can you just leave it?
If you're at the origin, we will all universally know that that means 0, 0. Are you saying like right here?
No, like I'm saying the numbers, you have to start with pi over 2, and you have to leave that in the test, you can just do
I get what you're saying. I do like to see some work. So my ideal world, you just show the work. If you're going to try to be minimalist, show the work on the first one, and then just write these from there. That shows me that you know how you get to the final answers. I'm always trying to make it so that you have to show your work, but not be unreasonable. So at least show me this much work that you did one of them. You know what I mean? Okay. Why don't I just want you to write the answer down? Because it's too easy to copy, because it helps me see what your thinking process is. And when it's wrong, it's really handy to be able to see in your work, like, where did the kid screw up, to help you. Like, oh, I see, this is what you did wrong. Otherwise, if there's just a wrong answer there, I don't know what you did. Okay, so that is a typical old simple graph sine cosine. Now what are you doing? Well, what do you think's next? We've done sine, we've done cosine, and now we're going to do tangent. Tangent. So if I'm going to graph tangent, first thing I'm going to do is remind you of some circle trig. Remember me saying we'd keep coming back? It's back. Isn't tangent the same as sine over cosine? Yes, it is. If it's the same as sine over cosine, then to see the graph of tangent, you could take every single point on the graph of sine and divide it by the comparable point on cosine, and that would give you your numbers. But that'd be really gross. So I'm just going to focus in on one of those things. Would you agree that whenever the cosine comes out to 0, then you'll be dividing by 0, which isn't even possible? Okay, so then wherever cosine is 0 is a big deal. So I'm going to graph cosine quick. I like to think of it in 4 points, to 4 parts. 1 part, 2 part, 3 part, 4 part. Okay, and this was at 2 pi. And I'm just graphing cosine. So I'm just doing it for a second because because I wanted to know where it hit 0. And where it did hit 0, it can't exist. So what can't exist? Tangent can't exist. I'm just going to go a little further with this. And I think you can tell that there'd be another one right there. And that was at negative pi over 2. Now I'm going to zero in on this one. That's the one I really want to focus on because it's around the origin. And it's the logical place to focus in on tangent is where it's by the origin. So here's what tangent really looks like. It's no longer a wave. It kind of looks like the x to the third graph. It looks a lot like the x to the third, x cubed. Now I'm going to go back and erase the cosine graph because that was just there to help me see why those asymptotes are there. You didn't really need it. It's just like a helper. Okay. Any other important points on tangent? Yep. Find where it's exactly between the y-axis and the, what do you call that thing? The asymptote. And put a dot there. And we'll label that as 1. And the same thing over here. We'll label that as negative 1. And last but not least, optional. I do not require this point to be labeled. But it's half of half pi, pi over 4, negative pi over 4. Yes, I said you do not have to label that. But it doesn't hurt, especially if you're doing something complicated, to be a little more accurate. Okay, yay, there's tangent. So now that is tangent. So what I'm about to do is like stretch it. Let's say I wanted to graph 5 tangent. You get I just put a 5 here and here. See what I mean? If I want to graph 5 tangent, you're just doing a vertical stretch just like before. Okay. What if I wanted to graph 5 tangent of 2 theta? 5 tan 2 theta. The 2, go through and multiply everything by a half. And I'd have pi over 4, pi over 8. I think you get the idea. So all the same changes apply. That's if I had to graph 5 tangent and 2 theta. I'm going to go kind of fast, but we'll review at the end. That was tangent. Yes?
So we need to graph, or we need to explain the exact asymptote x value?
Yes, the asymptotes are the only asymptote, or are the only parts of the x-axis that you have to label. So again, tangent from the top, that spot pi over 2, that spot negative pi over 2. Those are the 2 important spots. Those you have to label. That's good enough for tangent. Oh, wait, sorry. Plus the halfway spot. There. Okay. All right. Now, I could go on to a lot of different things, but I'm going to do the one that's like tangent. What do you think? What's like tangent? Cotangent. Here comes cotangent. It looks similar, but it's definitely different. Like an xy axis. Label it with cotangent. Don't just listen to me. You're never going to remember this later. Make the sketch of cotangent. Dotted line at the origin and over here. Do you remember how last time I figured out where to put the asymptotes? It was because tangent was sine over cosine. So wherever cosine was 0, I had an asymptote. This one is cosine over sine. So it's wherever sine is 0. That's where the asymptotes would be. So here's my phantom sine graph. I don't really need it. I'm just trying to show you. See, I can tell this is where pi over 2 is. I'm wrong. That's not what pi over 2 is. On sine, what is that? Thank you. And this is 2 pi. There we go. And there'd be an asymptote there too, because why? Because sine hits 0 there. Now, do you need 2 periods of this thing? Nope. I'm going to focus in on just this one. And I'm going to make a mark in the middle. I do need that mark because that's exactly where tangent will run through. So here's tangent. I'm making it green. Nope, that's tangent, Mr. Server. What are we trying to graph? So then it's a flip of that. There's cotangent. Now remember, the blue graph was just there to tell me where to put the asymptotes because I was doing cosine over sine, and so I was graphing sine just for a minute so that I could know where to put the asymptotes. That's how you can do it too, in case you forget. Dang it, I can't remember what, is that pi over 2 or is that pi? A really common mistake because in tangent, the asymptote's at pi over 2. At cotangent, it's at pi. How wide is this thing? Which means, how long is its period? Wilson, give it a shot. How wide is that?
Would that be 0, pi? Right?
For you're saying it goes from 0 to pi. How big is that? How wide is that gap? Don't overthink this. Yes, it is pi. All right, so then that means this thing's period is pi. Same with tangent. I'm going to go back to the tangent graph. Remember, this is my really quick tangent graph? Look at how wide it is. Half a pi plus another half a pi on the other side. Total, 1 pi. That's what makes tangent and cotangent different than all the other functions, is that they get over with in 1 pi. The other ones take a whole 2 pi to finish. This finishes quicker. Just 1 pi is the period, how wide it is. Okay. 10% remaining on my battery, so I got to cruise. All right, so we've done, that was tangent. This one was cotangent. Remember, this stuff over here was just extra. If you wanted to keep going, you could. I mean, tangent, cotangent could continue off this way and just keep going and just keep making them over and over and over. And it goes to the left too. So anyway. All right, there's tangent and cotangent. What is next? There's only 2 left. Name one. Secant. To graph secant, I'm not going to graph secant. What? That's kind of like when I asked you to do secant before. I said, this is the one time when I would encourage you to passively resist the math teacher and say, I'm not going to do secant, but I'll do cosine and flip it. It's the same idea. I'm going to not do secant. I'm going to graph cosine. You better know the basic ones because cosine and sine keep coming up. So back to secant is really the flip of cosine. So here's what cosine kind of looks like. 4 parts, 1 part, 2 parts, 3 parts, 4 parts. Okay, so that's what cosine kind of looks like. Why did I need that? Because if this is 1 over cosine, then wherever cosine is 0, asymptotes again. And what are those 2 spots? That's why I put it on here, because you know this one. You know it ends at 2 pi. You know that in the middle is pi. And then this one must be pi over 2. 1 pi over 2, 2 pi over 2, and 3 pi over 2. Now you know where the asymptotes are. The asymptotes for secant come from wherever cosine hits 0. Okay. Now, what did I do? I just erased cosine because I don't really need it. You know what? Wait, I'm going to wait on that. I'm not going to erase it quite yet. You can do the same. It's up to you. Here's the actual final graph. This is the actual graph of secant then. It's the green. I like to call them like parabolas. They're not actually parabolas. They're like parabolas. A long time ago in this math class, I taught you how to do the graph of 1 over f of x. And it had asymptotes like this. And you remember that was like you're supposed to draw the line so that you get closer and closer. And I called the dotted lines were like electric fences. And you get really close to them, but you don't touch them because it would hurt, and asymptotes aren't supposed to touch. So anyway, and then do you remember that they had weird loops like this too? And anyway, it's been a long time, but you did graph 1 over f of x, and they look similar to this because why? Because this is also the flip of cosine. Now I'm going to go back and delete out, I'll erase out the cosine graph because I don't need it. The actual graph is just the green part. There. Better draw back in my 3 here. There's the graph of secant. Now wait, that's a little lopsided. It's got 2 ups and 1 down. You know what they usually do then? They usually erase half of this one and half of this one, which kind of to me makes it hard to see what the graph really is. That's why I drew it the way I drew it. And now I'll erase them out to show you that's 1 complete cycle. Would you like it better if I drew it in like this and said that's 1 complete cycle? Because it is. I'd accept either one. But I have to label 1 more spot. But if I'm good at this labeling gig, I'd be able to say 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So if you want to do that, go ahead. But don't just don't put 2 upward loops and only 1 downward loop. That's not a complete cycle. That's 2 ups and 1 down. That's more than a whole cycle. So either get rid of this and do it where you've got 1 up loop and 1 down loop, or just do it right from 0 to 2 pi, and then it would just look kind of funny. That's secant. What's the last one? Cosecant. And then that's it. That's all I have to teach you. So cosecant. Passively resist. I'm not doing cosecant. I'm doing what? Sine. Because cosecant is based on sine. So everybody do a quick sine graph. You see why you really got to know those? I keep coming back to sine and cosine. If I'm doing cosecant, I got to have all these labeled 2 pi, pi, pi over 2, 3 pi over 2, 1, negative 1. And now cosecant is really 1 over sine. So wherever sine hits 0, asymptotes. Asymptote, asymptote, asymptote. Now, it's just like when we did secant. Do you remember what that looked like? I've never told you what cosecant looks like, but I bet you can figure it out. It's just like the one we did a second ago. You get what to do? What do you think?
It would be like the other one, except the one on the top would come up over the bottom. So instead of being like half and half.
You got 2 holes, 1 hole up and 1 hole down. Very good. You were correct. Looks like that. Do I need the blue one in there? When I'm all done, I'd erase the blue one. I see you did that too, and that's good. Because that was just there to help me. It wasn't part of the actual graph. Okay, cool. Now, remember, we're done with cosecant, but what if I put in 2 cosecant of 6 theta? Well then, I'd put a 2 here and a 2 here. And then what would I do on the x-axis? Multiply everything by? Not by 6, but by 1/6. Very good. See what I mean? I'm just trying to show you that is not cosecant anymore. That is 2 cosecant of 6 theta. And you just go through and do the same exact process, changing your labels, and you got it. Yay. Okay. Imagine for a moment you run into one of these. You might be like, what? That's the wrong chapter. Oh, we're done with that. I'm glad we don't have to do that anymore. You do have to do this. These are coming back, but only maybe one problem. So I'll just remind you, cosine of 2x, that's written on a sheet somewhere. For cosine of 2x, there were 3 options for cosine. That's one of them. Here's the 3 that I expect you to actually know. 4. I bet you somebody can finish this. Sine squared plus cosine squared. What's it equal to? 1. Good. That's one of the biggies. You ought to know that one. And that includes rearranging that. Like, what if I did minus cosine squared? And I do it on both sides. Sine squared would be 1 minus cosine squared. You ought to be able to swap those. You got to know those. Again, will we give you a sheet? Yes. But if they say 1 minus cosine squared, you got to be able to go, oh yeah, that's going to be sine squared. At least be able to come up with it by thinking. Okay, then here's another one you should memorize. The one with the coat. Somebody said, is what you seek. I thought that was kind of funny. If you're in Minnesota, yeah, you probably do want to steal their coat. But that's not the point. The one with the coat is, remember what the ending of that one is? Cozy. And the other one is the one with the tan is what you seek. Especially because they're eventually going to get skin cancer, and that's so attractive. I do know a bunch of relatives now. I'm old enough to know a bunch of people who are out in the sun a lot. My mom was out in the sun a lot. She used to be a lifeguard, and she got to be old, and on her face, she ended up getting a thing that she had to get cut off of her lip. I know another person loves the golf. It's about 67 years old or so. Been outside a lot playing golf. Had a big chunk of his nose cut out to take out the cancer. I know another person, big into sports. This one was on his leg. That was a little more weird because your legs don't get as much sun normally. Had to have a big chunk cut out. I know another person who was a fishing guide outside all the time, bald. What do you think got him? Top of his head. Because he's outside all the time and the top of his head gets all the sun. Then if you're bald, you don't have hair protecting it. So he got skin cancer on his head. He's had it there like 5 times. They keep cutting it out, and then more comes back, and they cut it out again. It's kind of sad, but my point, be careful with the sun. I love the sun. I love being out in the sun. But I think it's like anything. A little bit is okay, but a lot of it, very bad. I roasted myself one time. I just totally forgot. It was Florida, and it was 6 in the morning. We boarded the boat. What do you think I forgot? Sunscreen. Because it's cold. You're not thinking about sunscreen. It's kind of cold in Florida early in the morning. So you get out to the boat, and you're kind of cold, and you're driving out there, and it's windy, and you're cold, and finally they stop to fish, and the sun's out, and it's beautiful, and it's bouncing off the water, and standing there fishing, and you're finally feeling warm and good, and you're not thinking about sunscreen. Oh, I roasted so bad because it was middle of Minnesota winter, and I was down there, and I burned my arm so bad I actually got little blisters on my arm. Have anybody actually gotten blistered before? Oh, a bunch of you have. Okay, I thought I was the only one. Anyway, then that's a spot that I'm a little nervous about someday on my arm because I got a lot of little spots there. I'm wondering if any of those are going to turn into skin cancer someday. There's my public service announcement. Cover up. Don't get toasted. All right. And there's one more. I want you to know this one. Why? Because you're going to calc someday, and this is going to come up on the AP Calc test. And I'm going to be the one who's like, you'll come back and say, it was on there, Mr. Server. And I'll say, see, I told you needed to know that one. And yet, I bet you only 2 people know it in the room right this minute. Raise your hand if you know what sine of 2 theta is. Oh, Online person, yay. Bilderbeek, what is it? Yes. And for all of you that didn't know it, write it down. It increases the probability that you'll remember it because it activates a different part of your brain, which has a better memory system than the audio. Because if you had perfect recall of audio, you would all know it because I said it multiple times. I'm not expecting you to have perfect audio recall. Use every tool you can, like try to write it down. If you'd have painted it with your toes dipped in like lacquer paints, you probably would remember it right now because it would have been so visceral. All right. Okay, 2 sine, cosine. It's going to come up in today's homework. Now, one thing I want to warn you, today's homework can be like, oh, it seems normal. All of a sudden, what the heck is going on this problem? Remember, there's a key. Okay, look at it and you go, oh, okay, it's one of those identity things. You swap this in and then you factor it, and okay, then it makes sense. So don't get freaked out. Look at the key. All right, one last thought. I'll be specific on which one. There's one in here that I feel like is just outrageous. Hold on. These are all just one we could have practiced together. This one's actually doable, and if you draw it in circle trig, quadrant 1, it's not that bad. Cosine is adjacent over hypotenuse, 1 square root of x squared plus 1. You could figure out this other side here from a squared plus b squared equals c squared. If this is 1, what would this have to be so that this would be 1 squared plus x squared? Maybe x? All right, anyway. So I don't even need you to know. Dang it. That here's the page that there, this one. I thought it was different color. 28 and 30. You do not have to do that. That's just gross. Those are about impossible. Now, are you going to go do all of these? Not if you're a normal person. I strongly recommend that you go do some of them. And when you get stuck, look at the keys. It was unreasonable. And that'll get you well prepared for the test. Okay, when is the test? Well, we're just basically delving into this unit, so we got a lot of time left. All right. What do you do tomorrow? We're going to be grading a top 20, and we're going to be looking at that quiz called Starter Quiz. Okay, those should be Dropboxed by tomorrow morning. They were technically due today. And then we've made it. My iPad didn't even die yet. So I'm going to stop.